Hello everyone and welcome back to my YouTube channel. For the next few videos, I'm going to be focusing on the chapter light because it's an extremely important concept in physics, and I think that it's important that we get our concepts here. So, there are many topics in light, so I'm just going to break them into small videos, short videos, and keep on posting them every month. So this month's topic is reflection because that's one of the basic concepts that you must know in light. So without any further ado, let's begin with the video. Okay, so first let's understand what reflection is. Basically, reflection is, in simple terms, imagine a mirror, and the mirror is the reflecting surface. So when a ray of light is incident on that surface, on that mirror, it bounces back. So that's what reflection is. So when a ray of light is incident on a mirror, after reflection, it bounces back into the same medium from which it was incident on. So a ray of light strikes a mirror. After reflection, it changes its direction basically, and rebounds. Rebounds is a good word. So it strikes a mirror, rebounds, and that is reflection. So that is basically reflection in simple terms. If you want a much more detailed termed expression, you can check our textbooks because I'm just trying to explain what each of those terms mean. Now, coming to certain important parts of reflection, if you can call it that, but there are certain terms to know when reflection takes place. So, right now in this diagram, you can see an actual diagram of reflection taking place. So, certain parts, I can only think of the word parts. Okay, parts of reflection that you have to know. So this ray, which is incident, the first ray which is actually going to strike the mirror is called the incident ray. That's why we say that this ray is incident on the plane mirror. The plane mirror is the reflecting surface. So it can be anything really, the reflecting surface, but in this diagram it's the plane mirror. So this is the incident ray. After reflection, a new ray is formed that actually changes direction from the incident ray and rebounds back. That is called the reflected ray. So when a ray of light strikes a mirror, it rebounds back and changes its direction. And then the reflected ray is formed. So this is the reflected ray. And the point at which the incident ray strikes the mirror, that is this specific point from which the red line, I won't be referring to it as red line later, but the red line originates, is called the point of incidence. It's pretty important in the terms associated with reflection. And this is the point of incidence. This red line that we see is actually called the normal. And so basically the normal is a perpendicular line drawn from the point of incidence. So it's basically at 90 degrees to the plane mirror. And angles. So angles are pretty important, and I see that when people get confused with it. So the angle of incidence is the angle between the incident ray and the normal. This is why the normal comes. This is where the normal comes into play here, because it basically signifies the angle of incidence and angle of reflection. This is the angle of incidence. This is the angle of reflection. The angle of reflection is the angle formed between the normal and the reflected ray. So I see many people get confused that the angle of incidence is the angle between the incident ray and the plane mirror. It is not. It is always the angle between the incident ray and the normal. Just so you guys have a heads up about this whole concept, you might get numericals referring to this concept that deal with this concept, and if you do get it, I'll tell you. So this is just a simple numerical. If the angle between the incident ray and the reflecting surface is 30 degrees, so this angle is 30 degrees. So first you have to identify if it's the angle of incidence or this angle. So if this is 30 degrees, find the sum of the angle of incidence and angle of reflection. So coming to the next slide, you're going to be looking at some rules that have to qualify for reflection to take place. But yeah, I'll just tell you one. So if you can see the equals here, the angle of incidence will always equal to the angle of reflection. So what happens is, if this is 30 degrees, I hope you all know your math, an entire circle is 360 degrees, half a circle 180 degrees, and 90 degrees, because this is perpendicular. So we know that 30 plus something is equal to 90. If you do the math, you're going to get 60 here. So because these two are equal, this is going to be 60 plus 60, which is equal to 120, and your final answer is 120. So that's what your numericals are going to be like. Coming to the rules of reflection. First rule, as I told you, the angle of incidence is always equal to the angle of reflection. So always remember that the angle of incidence is always equal to the angle of reflection. Second one is that the all of the parts of the reflection, the incident ray, the reflected ray, the angle of reflection, the angle of incidence, the point of incidence, the normal, all of them lie on the same plane. That's the second rule of reflection. I have another rule. It's not exactly a rule, but it has to happen for reflection to take place. So basically, after reflection, the reflected rays form. So it's not only one ray of light that strikes the surface. There are many rays of light, but just for easier understanding, we only show one ray of light. But when many rays of light strike the surface, a lot of reflected rays are formed. These reflected rays, if they intersect, only will reflection take place. So basically, a requirement for reflection to take place is that after reflection, the reflected ray must intersect. At least two reflected rays must intersect. So that's another rule. Okay, so now we're going to be looking at images. So images are pretty important in reflection. So there are two types of images: virtual images and real images. So what's the main difference between the virtual and real image? So virtual image is actually an image that cannot be obtained on a screen. A real image is an image that can be obtained on a screen. So yeah, basically that is it. But there are certain characteristics of these images that make them different from each other too. So just to list some, you can make note of it. It's not that important. Virtual image is always erect, which means it's always straight, it's upright, and it is laterally inverted. Laterally inverted means that your left appears right and your right appears left. So if you stand in a mirror and you raise your right hand, it looks as though your left hand is getting raised. So that's what it basically is. A virtual image is not obtained on a screen, and in a virtual image, the reflected rays do not intersect, they appear to intersect. So if you look at this diagram, this is what a plane mirror always forms a virtual image. It always forms a virtual image. So we know this because if this is the plane mirror, this is the incident ray. There are two, as you can see, and then they get reflected. You have two different reflected rays of reflection and reflected rays basically, and you can see that they both are diverging. They're not coming together, not converging. They both are diverging away from each other. So we know that they're not going to intersect, but we still see the image in the mirror, right? We don't really see nothing. We still do see our reflection in the mirror. Why is that? This is because even though they're diverging away from each other and they're not actually intersecting in front of the mirror. If we extend the reflected rays, they're going to meet at a point behind the mirror, and this is where the image is formed. And this image is erect. So I will be coming into erect, real images, virtual and real images, etc. in my next video, where I'm going to be talking about mirrors and where the object is going to be placed for the image to be formed, all of that. So right now we can see that they are converging and meeting at a point behind the mirror. This is where the image is formed. So that is pretty much it. Coming to types of reflection are very simple. It's very simple. So we have the regular reflection and irregular or diffused reflection. So this irregular reflection is also called diffused reflection. So what is regular reflection? So in regular reflection, the only difference is the surface, the reflecting surface. And here it's smooth, here it's irregular. So when parallel beams of light, so when parallel rays of light strikes a regular or smooth surface, after reflection, the reflected rays so formed are parallel to each other. If they're parallel, they're never going to intersect, obviously. And thus, what type of image is formed? Say it with me. Virtual. Yes, you're right. So in regular reflection, a virtual image is formed because the rays do not intersect the reflected rays. But in irregular reflection, which is basically when parallel beams of light or parallel rays of light strike an irregular surface or a diffuse surface, after reflection, the rays of light so formed are not parallel to each other and intersect, forming a real image. So that is what irregular reflection is. I think we get it because it's a pretty simple topic to understand. That's it for today. Thank you so much for watching. I hope you guys enjoyed it, got a lot of information. tell me if you want to learn about refraction, dispersion, mirrors, lenses. I can talk to you all about it, but I will surely make a video about mirrors, because it's an extremely important concept. But concave and convex mirrors, it's extremely important. But if you guys enjoyed it, we're done. Comments saying that you want, what all topics that you would like to learn about. See, I'm an eighth grader going to ninth, so I don't have a lot of information about higher things. But like, if you guys want a simpler topic to be explained, just ask me and I will do it for you guys. Thank you for